then this one. So this mole is not that mole that we saw in sound. Okay, it's not a creature right now. It's a unit. Mole is a unit. So before that, we have to talk about this thing called particles. Okay.
Oxygen, water, sodium chloride.
Particles. Okay, so you see the words particles everywhere in your physics and chemistry. You see these particles. Okay, so
The
particles.
kinetic particle theory.
Yeah, so you see the particle, this word particle floating everywhere. But what is actually particles? So you have elements and compounds. I am very sure you know that. Then in elements and compounds, you have particles. So in elements, right, the particles are actually atoms and molecules, because atoms, they will exist like that as a standalone. Elements, they can also exist as molecules, like paired up, like oxygen. You get two oxygen in one molecule, so you get particles. Oxygen. Yeah, so oxygen like this, it is also a particle. Molecules are particles. Then in compounds, you will have molecules as particles again, and ions as particles. So you get covalent compounds where you have hydrogen and water, they come together, they form water. So then the molecule, the water molecule is a particle. Then in sodium chloride, the sodium ion and the chloride ions are all particles. Okay, so then you're the mole. The mole definition is not tested. You need to know what the mole is, but they will not explicitly ask you in a structured question what is the mole.
Then the Avogadro's number is tested.
The Avogadro's number is tested, but the mole definition is not tested. So you have something which is 1 mole. Okay, so you have something which is 1 mole. So in 1 mole of a particular substance, you will get 6 times 10 to the power 23 particles. Because a mole is defined as the amount of substance which contain the Avogadro's number of particles. So 1 mole, you get 6 times 10 to the power 3, 6 times 10 to the power 23 atoms. So it is 6 times 10 to the power 23 atoms, right? Is the mass of 1 mole of carbon, which is the mass of 12 grams.
It's Avogadro and a person.
Yes, it is. So in 1 mole of carbon, there's 6 times 10 to the power 23 atoms. So then in this 1 mole, there is 12 grams of carbon. If you dislike Avogadro's number, you can think about that guy. So in this situation, we have this example. You have 1 mole of sodium atom. 1 mole of sodium atom will contain the Avogadro's constant, which is 6 times 10 to the power 23. Then, yeah.
Then all is 6 times 10 power 23.
Yes, that's correct. 1 mole of silver ion also 6 times 10 to the power 23. So
While 1 mole of electrons.
1 mole of electron is also 6 times 10 to the power 23. So the purpose of this example is to tell you that if I say 1 mole of something, it's always 6 times 10 to the power 23 of that thing. So I say 1 mole of silver ion.
Compounds that contain two atoms.
So 1 mole
sodium
of
chloride.
okay. 1 mole of sodium chloride means you have 6 times 10 to the power 23 of sodium chloride. Okay,
this is 6 times 10 power 23 because it contains 2 atoms.
So the question is like this: 1 mole of this contains 1 mole of this. So you have, but this can split up into this, right? So 1 mole of sodium chloride contains 1 mole of Na plus ions, and another 1 mole of Cl minus ions. So if they say how many moles of ions are there in 1 mole of sodium chloride, then you become 1 mole of sodium chloride has 2 moles of ions. English. The word play will cause your answer to change. You there? Yeah. The word play will cause the numbers to change. So you see this example too. You have 1 molecule of water contains 2 hydrogen atom and 1 oxygen atom, right? So your 1 mole of water molecule contains 2 moles of hydrogen and 1 mole of oxygen. So which means you have 2 times 6 times 10 to the power 23 of hydrogen atom, then 6 times 10 to the power 23 of oxygen atom. But down here, it contains 1 mole of water molecule is 6 times 10 to the power 23 water molecule. You see the thing? You see the word play? So if they say 1 mole of molecule, that means it's 6 times 10 to the power 23 molecules. Then if they say 1 mole of water molecule has how many hydrogen atom? That is 2 times 6 times 10 to the power 23. Okay, next one. So you have 1 molecule of ammonia contains 1 nitrogen and 3 hydrogen atoms, right? So then 0.5 moles of ammonia contains 0.5 moles of nitrogen and 3 times of that, so it's 1.5 moles of hydrogen. So then the numbers here will become 0.5 times 6 times 10 to the power 23. Then this one will be 1.5 times 6 times 10 to the power 23. Okay, all right.
Yeah.
So another one down here, you have 1 molecule of aluminium sulfide. So 1 aluminium sulfide has 2 aluminium and 3 sulfur atoms. So then in 1.5 moles of aluminium sulfide, you'll get double of 1.5 because double of aluminium like that, and then 3 times of sulfur like that. Then this answer will be 1.5 times 2 times 6 times 10 to the power 23. Then this is 1.5 times 3 times 6 times 10 to the power 23. Like that. Okay? Yeah.
Yeah.
Then this is the one with ions. So 1 molecule of sulfuric acid contains 2 hydrogen ions, 1 sulfate ions. So in 1 mole of sulfuric acid molecules, there is 2 moles, so 2 times, and 1 mole of sulfate. Then this one, right, is 2 times 6 times 10 to the power 23. Then this is 1 times 6 times 10 to the power 23. Can? So that's counting. Then, can I move on? Can I? Yeah. So your syllabus, there's this molar mass. So can I continue?
Yeah.
Okay, so after counting all that particles, right, then you have this one, which is the relationship between the mole and a reacting mass. Reacting mass means in an experiment, the amount of substance you use. So if I have a reaction and then I have to put in a certain amount of metal and a certain amount of other substance for the reaction. So this reacting mass is the amount of substance that I put in the reaction. So before that, there's this concept of molar mass. So molar mass is the mass of 1 mole of substance. Then molar mass is also this one. Then it has a unit now. Molar mass has a unit. Okay. So if your reacting substance is an element, then the molar mass is your relative atomic mass. If your reacting substance is a diatomic gas, that means it's something like oxygen, then the molar mass is the relative molecular mass. Then if you have covalent compounds or ionic compounds, let's say ammonia or sodium chloride, then your molar mass is relative molecular mass too. This one important. Okay, you're alive there?
Yeah.
So you have relative atomic mass and relative molecular mass definitions on here. So your relative atomic mass is the mass of 1 mole atoms in grams. Then relative molecular mass is the mass of 1 mole of molecules in grams also. So, okay, back to just now, this one you see here. Back to this, you see this formula. So, they say number of moles is mass over molar mass. Yeah, remember that. So, number of moles is equals to mass over molar mass. So we are given question 8a. They say calculate the number of moles of the following atoms. Then you know if it's atoms, molar mass is the relative atomic mass. Okay, so then the info given here in the question is the mass, or you call it the reacting mass. So number of moles is what you want to find right now. Then the reacting mass or mass is 0.6. I take the info, I substitute into my equation. Then the molar mass for carbon is the relative atomic mass. So what is the molar mass for carbon here? This, correct? So then using the calculator, you will key in these two numbers and then you will get the number of moles as 0.05. Then you write mole. This is how you do a question like this. Okay, any issues? Okay, so I'm gonna show you some more. Okay, then I'll give this question to you. So we start with number of moles is mass over molar mass. Number of moles equals to mass over molar mass. So mass is the reacting mass here, which is 10. Then your molar mass is the
40.
40. Okay, next one. Remember your units. 1.7 divided by 14, 0.121. And next one, 39. You want to check your calculator?
0.376.
So are you doing 3SF or 2SF? If it's 0.30769, okay. 3SF means you drop the fourth SF.
0.308.
Yeah.
0.308.
Yeah. So what you do down here, if you want a 2SF, then it will be 0.31, then drop everything else. Then you shouldn't have a 0 if you want to do 2SF. 3SF, then you drop like the whatever I said.
Means you can choose if you want to do 3SF or 2SF.
3SF. Usually 3SF. Unless you are given further information in the question. Like certain question, they will tell you, they'll show you how many decimal places you have inside the question. Then you follow the one that has the least significant figure. Next one. Now this is a little different. Okay, they say calculate the number of moles of the following substance. Carbon dioxide. So the first, okay, so number of moles is equals to mass over molar mass. So because this is a compound, then molar mass is equals to the relative molecular mass. Relative molecular mass. Okay, so that means your first step to this question is to find the relative molecular mass of carbon dioxide. So you have to find 1 carbon plus 2 oxygen. 1 times 12 plus 2 times 16. So 44. Then number of moles is, I don't know. Mass is the reacting mass given by the question here. So this is 2.2. Then molar mass come from here. So 44. 2.2 divided by 44 is 0.05 moles unit. Okay? So same as before, I'm going to give you the question and then you will attempt. Please write your steps clearly. So relative molecular mass is equals to 1 calcium plus 1 carbon plus 3 oxygen equals to 100. So that means 1 times 40 plus 1 times 12 plus 3 times 16. So you show me that 100. You have to show this. So then number of moles is mass over molar mass. So it's 12, 25 divided by 100. Next. Relative molecular mass is 2 times 16, 32. So then you have to write number of moles equals to 4.8 divided by 32 units. Next one, relative molecular mass is 24. So magnesium sulfate, 24. Sulfur is 120. So then you take mass over molar mass. Okay, units. Wait. This is not molar mass. This is number of moles. So number of moles is mass over molar mass equals to this. Okay. So for question 10, we apply number of moles equals to the mass over molar mass again. So which also means that we need a periodic table. So when we see such a question, first thing to do actually is make it convenient for yourself, right? Just identify the elements and write down the atomic mass. So sodium is 23 and chlorine is 35.5. Calculate the mass, right? You see? So the number of moles is given to you. Then you first have to find the molar mass. Is NaCl, so it's 23 plus 35.5. Then you get 58.5. Then 58.5 goes to here. Then the number of moles goes to here. Then 3SF, then you get 29.3 units. Okay. This one, presentation. Number of moles is mass over molar mass. So then mass over molar mass. Chlorine gas. Remember your periodic table chapter. Chlorine, if it's a chlorine atom, then it's Cl. If it's chlorine gas, then it becomes Cl2. Let's see. Why the difference? So
it's 0.7.
uh,
Then I put 0.3.
so it's 8. 0.8.
Yeah.
But careful, this question. Maybe tricky. Think carefully. First of all, give me the formula, chemical formula for potassium carbonate.
K2CO3.
Okay, how can you improve your presentation? So number one thing is, okay, you have your formula. Then second thing is you have the molar mass. So what you did was you will write down this. The next line, the first line you should write is the molar mass is how much. You did this, you get an answer. So 9.1 times 2 plus 12 plus 3 times 16. So you get 138 point. Your periodic table got 39 only. So it's like that. Then after that, you write. First step, you write this. Second, you write this. So second, you write this already. Then you insert your formula. Then mass is mole times mr, like that, equals to this. Then how do you get this? 0.02 times 138 number of moles times mmr. Something wrong there. Then what are you short of? Something is missing. What is it? Units. Okay, there you go. So this one connects the number of molecules and the number of moles. So let's recall again. Number of moles is equals to mass over molar mass. It's also equals to the number of particles over 6 times 10 to the power 23. So let me just do an example. Let's look at, say, carbon dioxide. So number of moles of carbon dioxide, this one will be mass of carbon dioxide divided by mr. So I get 0.1 mole. Then for here, number of molecules would be the number of particles. So 0.1 equals to number of over 6 times 10 to the power 23. So multiply will give me 6 times 10 to the power 22. So this answer would be 0.1 and 6 times 10 to the power 22. So we will not do all. So let's just do, for you, just do this and this. Let's check. So ammonia is 3 and what's this? So you do number of molecules is, this one will be 3 times 6 times 10 to the power 23.
1.8
And 10
times
to the power
10
20.
power 24.
Okay, then the last one is 2 and 1.2 times 10 to the power
1.2
24.
times 10 power 24.
Okay, so the rest don't need. Then again, we are not going to do everything. So this is a table relating mass, molar mass, and number of moles. So we will only do, you want to do everything? Okay. We will actually have you to do the last two, this two. Yeah.
Yeah,
Okay, let's see. The last two, correct or not?
yeah, correct.